ATS Inspect is a software solution that will improve your right first time and prevent defective products from leaving the plant, which will improve and protect your brand reputation. This is achieved by identifying defects using 3D CAD models, by utilizing dynamic electronic checklists, and with near real-time analysis made available anywhere in the world. Let's take a look at how ATS Inspect can help people in aerospace operations by going through an example of defect entry, defect repair, and repair confirmation using the Data Collect application within ATS Inspect. We'll start by logging in as a quality inspection engineer. When you log into ATS Inspect, it knows your role and can enable and disable various features to help you work more efficiently. The screen layout shown is only an example, and you can modify it any way you want so that you've only got the elements that you need. One important element to note is the use of tabs, which will allow you to access everything you need in one place. As a quality inspector, we'll start the inspection by creating a unit in the system. This information can be imported automatically from your PLM system, but here we'll create it manually. Enter all the details requested that identify the unit you're inspecting. Again, this information is completely configurable depending on your requirements. Now that the unit is created, we can log the defects we find on it in the Defects Entry tab. ATS Inspect allows you to enter defects using both 2D and 3D views. You will only be shown views that apply to the unit you've selected. Let's have a look at a 3D view. Although you can freely rotate and zoom the model, you can also use bookmarks. This will move the model into preset positions and add and remove components from the model depending on how the bookmarks have been configured. So let's add a defect to a turbine blade by simply clicking on the location where the defect was found. We can then specify the type of concern, the rank or seriousness, and the area and cell responsible for the defect. We then have the opportunity to add further information in the comments section that could aid the repair operator. The defect can then be seen on the CAD model. As soon as a defect is recorded, it can be reviewed by repair teams. If the defect triggers an alert, then the responsible personnel will be informed by email or via overhead displays. Alerts can be created for many different requirements, such as a defect being recorded on a critical component, or too many defects being recorded over a given period of time. Now let's look at the electronic checklist. The checklist contains questions that need to be answered for the unit. This could be to do with the physical qualities of the product, or to confirm that the correct custom features have been installed. The list of questions presented is dynamically modified so that you only see questions that are relevant to that exact unit at that exact station. You'll also notice the steps control up here. This allows complex inspections to be broken down into more manageable steps that guide the operator through the process. Each step will have different views and questions associated to it. You can also set rules to prevent invalid answers, or to show when answers are incorrect, and you can even create a defect on a component if an incorrect answer is entered. As you can see, some questions have documents associated to them. These give the operator further information that can help them select the correct answer. So, now that we've recorded the defect we found and answered the required questions, let's imagine that we're at a different location and log in as a repair technician. If we go to the Defect Entry tab, we can see the same views as were shown at the Defect Entry station and, more importantly, we can see the defect that was entered. Once the repair has been carried out, we can click on the defect and enter all the required repair information, including any additional comments and the length of time that the repair took. As you can see, the flag has changed from red to green to show it has been repaired. The final step of the repair process requires a member of the quality management team to confirm the repair has been carried out correctly and meets the required standards. So let's log in as a member of the quality management team. If we go to the Overview tab, we can see an overview of all the defects and repairs that have been entered on this unit. Selecting a repair gives us some new options. If we decide a repair doesn't meet the required standards, we can reject it. However, if it does meet the required standards, we can confirm it. We'll finish by looking at one of the key strengths of ATS Inspect, which is its reporting and analysis capabilities. Analysis of the defects and repairs entered in ATS Inspect is available from within the Data Collect application, giving operators insight into issues as they arise. ATS Inspect comes with a wide range of pre-configured reports that allow the operator to see which are the most common defects and where they most commonly occur, as well as tracking quality over time so that patterns can be identified. And if the right report doesn't already exist, you can create it yourself. With ATS Inspect, you have all the tools you need to collect and analyze your product quality data, allowing you to monitor and improve your aerospace inspection processes.